All right. I guess I'll get started, and thanks for inviting me, Neil. All right, so I'm going to talk about our experience on building some new fabrics in our national data centers. So with that came a lot of experience with, I think, some curious topics of what's going on with white boxes, what's going on with OSs like Sonic, and other variations. And we kind of came to a conclusion of we ended up going in a somewhat vertically integrated situation, but still getting the same user experience across multiple vendors. So wanted to share that experience with everybody. So I'll go ahead and get started. Let me see if everybody can see that. So a little bit of introduction. So I do manage a team of data center network architects at Comcast. What that covers is data center networking, services, and public cloud connectivity. I've been on both sides, vendor and the operator side. Now, the agenda that I'm going to cover is basically our problem statement was how do we actually provide networking services to our customers a lot faster, given that people's user experience and expectations were changing as public cloud is available. So that was a pretty tough proposition to compete. So we wanted to improve, not beating it as hard, but definitely wanted to improve. The other items that I want to talk about were, okay, so what were the components and what kind of decisions did we make and what we put together, share some of those experiences and give a quick summary. We definitely had some sweat equity and battle scars, so we'll definitely talk about that. That being said, you know, we were making a lot of just-in-time decisions, so anything that we could have provided the service in 3 days, it typically took around 4 to 8 weeks, so we wanted to kind of coordinate that where we remove some of the human interaction and also already move away from the just-in-time. And to do that, we needed to drive economics. So we needed to lower the cost in comparison to what we were doing today. So that was important. The other thing is, regardless of the cost, our 5 to 10% spend was holding off 80 to 90% of the spend. So that's definitely not a good thing. So it's definitely better to make that cost, spend that money up front to make a serviceable environment immediately. So it's not always just automation. It's some of these strategies that we had to change. The other thing is when you're not building things in front, lead times are serious. I think coronavirus and a lot of these things are affecting some of those lead times. So a lot of people might be already facing this. The other thing is the lack of bandwidth actually created a lot of shadow networks. So you can see the little picture right there. So they started creating little spine networks of their own and, you know, kind of didn't use the structured cabling and threw those cables across. So, you know, definitely it gave us the, oh no, you didn't kind of approach in those data centers. It was definitely not fun to see those type of things happening inside of our data center. Also, whenever we actually introduced a new OS, even though it's the same role, having to refactor those tools were just incredibly painful. We're a small team. You know, we're not one of those web scales where we have 250 software engineers behind an operating system and, you know, 20 engineers, you know, just refactoring different types of transceivers. So we had to actually align to who we are. And then training ops. I mean, we get a lot of pushback. We rely on them heavily. They're a very important part. So, you know, when we bring a new OS or bring something new, it's always just been heartburn. So I think that's something that we wanted to resolve. And then a lot of our customers, they wanted more ownership of the rack. So they wanted to bring in the rack, more rack as an appliance and end-to-end control as the features are kind of moving down to the leaf layer. So these were kind of our problems. You know, how do we adapt to these? How do we actually service our customers? How do we stop that shadow networking and et cetera? So we said, all right, you know, we'll take a product-like approach. That being said, what we mean by that is, okay, why don't we turn into like a black box and give them the expectations to our customers. So we said, okay, you know what, default, we'll give you 800 gigs no matter what. All the structured cabling's laid out, everything's ready to go. You know, we give them, you know, we remove the distance issues. For example, we do allow for 500 meters to 2 kilometers in our data center. We went fully single mode. We had larger data centers that 100 meters didn't do the job or 150 meters didn't do the job. So it was another decision point. So automating that was a pain. So we actually said, all right, we're going straight single mode. We give bandwidth, lots of bandwidth. That was the reason why some of these shadow spine networks appeared and people, started throwing cable across rows and rows. So we wanted to solve that. So we gave 1-to-1 for east-west, and then for north-south, we guarantee 1-to-8, but it's typically better. Latency, that was another thing that we always got complaints on. We always deliver specific console cables, so we actually pre-build these management pods and everything, so all of the stuff is actually there, and then we kind of guarantee it. We typically range about 15 to 16 drops into a rack to service, bring up one of their rack as an appliance service. So this was one of our first areas that we wanted to focus to solve. Obviously, we have other ones where we do own the rack, and we provide different solutions, but it was kind of out of scope for the discussion, so I kind of left that to the side. So some of the things were, how do we lower the cost dramatically so we can actually throw lots of bandwidth at the problem and it's always there? The other thing is the structured cabling and us, we were kind of like in silos. We weren't working together, so it was always kind of discoordinated. We really coupled tightly, even included the cost structures, and really made a lot of that decision making together, and that kind of helped out. Again, that single mode. I think what we're seeing is that inflection point taking place where single mode for us on 400 gig E was definitely more economical. Component, they were actually a little bit slightly higher, but when we combined it with the structured cabling that's needed, because multi-mode needed a lot more strands and everything, it actually ended up being a little bit about a wash. So that was a good thing. And then we're seeing that its pricing is only getting better for us. So the other item is when they brought these racks, we wanted them to be able to just make a REST API call. All they have to supply is, hey, what's your region? What's your suite number? And then give me the rack information that you got from the data center engineering, data center facilities folks. And once they plug that in, make that REST query, they got all the parameters. Of course, there's an authentication piece to it, so it is secure. They'll take that, they'll integrate that into their pipeline and actually output their playbooks to automate their rack as an appliance per se for all the network connections. So we kind of become a transport like solution. So we also wanted to add the other issue. I'm sure a lot of people are using this terminology, mean time to innocence. So we wanted to add certain tools. So we added heat maps where we would run a container agent, or direct if it's a Linux-based, a modified Linux-based operating system, we would just apt-get a specific agent, and we would put that onto the management switch, and then our management switch would be in-band, so it'll look like it's just another server in between the two leaves, and basically we have this continuous ping mesh. What we did was we integrated that into Teams and Slack, so you can actually say, hey, bot, give me the heat map for the last 60 minutes in Ashburn, blah, 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 suite, whatever, and then basically it'll output a heat map saying, hey, your latency from rack 1 to 9 is good, but maybe rack 1 to 8 might be high, so we actually give this a heat map color, which you might see a little small GIF that I took out of that image there. So we did give a little bit of chat ops-like feeling, so we're continuing to improve that, so we do some of those kind of capabilities. But, our goal was to definitely take a product-like approach and then continue to enhance that as customer needed it. We overbuilt the ports, so even if we consumed 800 gigs and typically it's 200 racks, the reason why we have so many ports were we had some customers that needed a lot more capacity. So that being said, what were we looking at from a components standpoint, right? So just, this was a fiasco. I mean, it was just so many, it's a great community. It's a great ecosystem. It allows a great competition. So it allowed us to get some great economics. But what ended up happening was, wow, that's just a lot of meetings that we had to go through to understand the economics and all the options and everything. I mean, we weren't looking for white boxes. We weren't looking for Sonic as an OS. We were curious, definitely. It always tickles our curious bone. But we looked at everything, and then what we came to was, okay, let's kind of standardize on the 32 by 400 to build out our core fabrics inside of our suites or inside of our data center suites. So we standardized on that. And then there were two parts, you know, the 400 gig DR4 and then FRs that we kind of standardized on. And then the 2-meter DAC. And you're going to, you know, because we were trying to lower the cost, AOCs were just a little bit out of our price range to build these core fabrics. So what we did was, what ends up happening is we created these like mini fabrics, and then we create these spine groups and deploy it into our data center suite. And what drives the decision process on which fabric size to use, it's always how many racks are in that suite. What type of space do I have? Do I have power to the rack? You know, do I have consecutive racks available? So like if you look at the extra large, we had to put 16 switches in the left side, the middle, and then the right side. And then we also pack in a lot of the structure cabling that goes with it. So that required a lot of flexibility, 16 kilowatts, about 16 kilowatts max draw. And then, you know, we would weave in the DAC cables. So the DAC cables will weave in the middle. So there's a picture. So we kind of took, you know, some vNYNOG presentation. We liked it. It was from Verizon Media, and you know, they had a picture of this, and we said, yeah, that's exactly what we want to do to be a little bit cheaper. So the super spine in the middle, we got the 400 gig 2-meter DACs, and we weave in, and then we kind of created this tier structure, tier 1, tier 2, and then T0. And kind of created these mini fabrics, and then we can scale up to 4. So these fabrics have 256 to 2048 ports. We kind of cluster it together. We have a console server that's attached to it. We relied heavily on ZTP. And then after all of these dealings, what we ended up saying is, you know what? I don't want to refactor the automation, so, you know, it's not identical, but it's kind of close enough. So we realized we ended up with kind of 3 players. Some of the things might be supplied by OEMs, but what it really boiled down to was that the suppliers were Avago for the MPU, and then also the transceiver was coming from Avago. So we said, okay, you know, that'll work, you know. And then NVIDIA, obviously, you know, with their Sonic, and then you know, the transceivers coming from them. In their case, they also provided the DACs where they owned the componentry, and then Intel the same thing. You know, we saw the 32 by 400 silicon, and so we saw these vertically integrated kind of stacks, if I have to say, between these vendors. Maybe they're kind of masked by other vendors, so you know, other vendors do utilize it and build their own, but we kind of ended up with these 3, and we said, okay, you know what, this will work, because the other issue was finding out all the transceivers that would work with that platform. Are they going to work? Coordinating that, it was just too much. So the way we we solved a couple of problems with this, basically going through the fiasco of optics certification. The other thing is, you know, we're getting you know, silicon diversity, but we're not sure if it's going to render great results or whatnot, but it does give us silicon diversity. We'll look at it as a positive for now. But what it did was it gave us very little refactoring of our playbooks that were needed here. So we kind of ended up with these kind of 3 players. What are the ODMs, you know, that puts sheet metal behind it and sends us, you know, those are, you know, yes, there's vendors associated to it, but we ended up with these 3 players. And you know, for 2 suites, we went with one. For the next 4 suites, we went with another. We're thinking, you know, maybe if we feel safe enough or we can drive more cost out, we might, for the next 3 suites we're building, we may go with a third. So those are all kind of formulated. We actually kind of decide on the cost structures and whatnot on which one to go with, and then we answer those questions. So again, you know, a lot of the power space cooling is important on which t-shirt size we go with. As you can see, I just wanted to kind of give our numbers and percentages of, you know, typically our suites are about 200 racks, you know, maybe like about 4 suites per data center of average size. And in there, you know, we were this core connectivity, we were able to kind of reduce it by about 80%. So we said, okay, now we can splurge and have a, you know, move away from that just-in-time model. and then, the structure cabling costs did go down, and then, out-of-band management packs and everything, we were able to reduce it by 38%. So net with that reduction, we said, all right, we can actually build these things out, move away from just in time, and then give some parameters that are kind of more easier for our customers to consume. That being said, hopefully I can move my slide. What is the connectivity like? What's the structures look like? Sorry for these very busy slides. Apologies ahead. We actually, for smaller environments, let's say I only need, about 100 racks, then you can actually put those small t-shirt size, split it out into 4, and then actually, you can see the ratio splits and et cetera. Our standard is to supply 800 gig. And then basically we have, if we really have a large suite, so if you look at our West Coast suites, they're super large. So they're equivalent of like maybe 3 suites. So in that case, we would actually go with the extra large t-shirt size, and that'll allow us to go up to 800 racks. So these are kind of the flexibility, the reason why we had to actually come up with t-shirt sizings and how we actually lay it out so we can actually cover most of our general use cases. Prior to this, we were using high buffer systems. We didn't have RDMA traffic. We didn't have much lossless needs. And we said, you know what, we'll throw a lot of bandwidth at the issue. So that's where we kind of got a little bit of a 75% latency reduction, space reduction and power reduction. If we used equivalent against the equivalent components, if we just stuck to those components that we were using before. So today, those bring your own tour model, or those customers that are coming in to the data center who ask for the services like the cloud team. We have a lot of cloud teams. One might be more open sourcey, one might be more, commercial, be it VMware and others. In that case, they would say, "Hey, give me a rack space. I'm going to bring in X amount there," and then basically the customer rack gets sent. Those connections get patched. They already have pre-existing patch cables because they're all deterministic. And then after all that's plugged in, we don't get involved. We don't have to talk about, hey, our AS number is this. This is your, point-to-point address. All of that is actually provided. This is actually a real REST API query to our production system, so I had to black out a lot of the things. So apologies. It may not make sense, but we distribute all of the loopback addresses of ours and theirs, and basically the remote AS number, the point-to-point addresses. The one thing we don't have that they have to actually go query themselves is bring their own spaces regarding their applications. But most of the point-to-point links, they make a REST API query, they put that into their pipeline, and then these racks automatically come up. So that's kind of the method. For those that might be curious, okay, what does that, one of those grouping of switches look like for our extra large? For example, on the left side, we would put 16 32 by 400s. In the middle, we'll put 32 by 400, and then we'll put another 16 32 by 400 on the right side. So those are ranges. And then we actually use, for the left 1 through 16, we would use the 16 ports on the right and then connect that with the DAC cable. On the right side, we would use the left 16 ports, and then we would interweave all that DAC cable so it formulates one of those large clusters, and then we would put 4 of those. As you can see in this example. So for example, this is a REST query to CF123. So what our customer would do is write that pipeline with typically Ansible playbooks, and then they'll make that REST query based on that CF123 where their rack location is. This is a portal that we do. Actually, these are real screenshots. So we do actually provide that portal once they get the rack number. If they don't have a method to make REST queries, they still want to hand type the configurations, they just have to click on it, and then we actually put a nice table where it actually gives all the parameters. So we still accommodate customers that do not want to take API-based approaches. So that being said, we lay out a side and a B side. So for example, for this suite that you see right here, we have an A side and a B side. So we went with the large side. Large size t-shirt, if I have to say, as you saw earlier, that gives about 1,024 ports. two fabrics combined, that's 2,048 ports. You can kind of do the math of like each rack consuming 800 gig ports, and then you can see, okay, well, that's still at 200 racks, that's still only about 1,400 ports consumed. We leave the other 600 plus ports for customers who need more than 800 gigs, and then we can actually provide that in an automated, systematic way, or we can actually, give more north-south, improve the north-south ratio. So these spine groups, we actually, this is our suite layout, but you can see that the spine group will go into one network row, another one will go to another network row, all the structured cabling are pulled, the purples are in middle row, and then literally all this stuff is actually already pre-laid out, so our customers can actually move real quickly. So we're able to actually get a lot of this stuff down from weeks to days for them to bring up their rack services, actually sometimes very, very fast, depending on the timing of it. That being said, for those that are curious, what happens, how does this all happen? So when we build these fabrics, how do we minimize a lot of the, how do we simplify it? We use ZTP mainly. Ansible's mainly built to generate the pre-existing ZTP configurations, not necessarily pushing the device configurations, because we pre-provision everything. We're constantly improving the features on the REST API where they can actually turn up, turn down the BGP. We do get a little bit nervous when we allow our customers to do that, just in case they don't do a REST query on somebody else's rack and then shut down their BGP. So we're trying to figure out more of that. So and this is why we're treating it like a product, because we have to continuously add these capabilities. So they file all of this in GitHub issues, and then we actively resolve these items. But as you can see, there is still some manual part where somebody racks and stacks, and then they get the MAC association and everything, they register it, and then we have an intake repo. So that's where the human element comes in. And then once that is correct, then there's a playbook that actually does a generation that generates all the packages necessary. So we get the package, and then we have another playbook that just pushes it to a console server that we actually made a ZTP system out of it, where everything gets booted up from there. So that being said, what does that ZTP kind of zero-touch provisioning looks like? So we have a console server. We have obviously we have 4 containers running on a console server. We have a generic DHCP, and HTTP server for some of the Arista stuff that we have, some of the all the Sonic core fabric devices, and then also the Nginx for the NXOS devices that we boot up. So we actually separate the containers just to kind of keep it siloed, and it was easier for us to troubleshoot. For those that might be asking, why did you separate each web server? That's kind of awkward and weird. It just ended up being a behavioral thing that worked out. It could have been just one giant container within Nginx and then different port numbers, but it worked out better for us as we can actually generate each one separately. Why did we use a console server to host all this stuff? It was just always this chicken and egg issue. We always knew that we have to put a console server in, so we were like, okay, you know what, just put it on there. There's enough CPU horsepower, memory, and hard disk drive, and that's a starting point. There are always something that we actually have to type in. So that's where we looked at it. So for those that are curious, hey, what kind of tools did you use to make that thing happen? Obviously we stuck to what our standards were. We didn't go out being creative of bringing our own tools. We wanted to kind of go with the tools that most people were using around us, and that was GitHub Enterprise for configuration management. It was Ansible, sandboxing, and a lot of stuff. We kept it vagrant so we can actually transport that sandbox between each other when we do the testing. Concourse is our CI/CD pipeline. It gets a little bit complicated for those that actually play with these things. So we were still kind of looking into GitHub Actions because we didn't need a very complex pipeline for what we do. We do actually have that ping mesh agent that we do support. We did play with Batfish. Sonic support was lacking, so we'll revisit that some other time. Coding, mainly Python, Bash, and JavaScript, and we use things like Node.js to provide those REST API calls that you saw. So just want to kind of, it's always curiosity strikes on what people are using as their kind of development environment. So, for us, we split into 2, Atom and Visual Studio. And I think Visual Studio was more mainly driven by that we had to build these REST API, and there was a lot of goodness built into it. You know, the features, this is where we had to be very disciplined when we used OS like Sonic. You know, it's not a negative thing. It definitely provided the structure and discipline that we kind of needed. That being said, you know, OS is kind of uniform even across multiple vendors. You know, we needed the ZTP features. I'll talk about something that was really cool about it. And then a BGP v4, v6, LACP for any liveliness of those links. So it's all in port channel, even if it's one link. We do use LACP fallback because we do ZTP in-band to the leafs, and then we also load some containers directly on the switch to support those ZTP mechanisms. SNMP syslog, we're still working the GNMI angle. You know, there's some hooks that we need to kind of get it right, so that's still in the works, but you know, all the SNMP syslog, all that stuff is working fine. You know, obviously we're doing port breakouts, you know, for the 400 gig DR4. Obviously, for those that know, you know, it does have a gearbox and then it splits it out. And then on the other end, we use typically 100 gig DR or FR. You know, we can use both. They're compatible. We tested both. We typically, when we see the economics fall more to FR because they're very similar in nature, we just go ahead and go with FR, which is the 2 kilometer one. So we kind of splurge if it's like $10 to $20 more. We would just splurge on the 2 kilometers instead of sticking to DR for those that might be looking into single mode for their data center infrastructure. TACAX radius, that worked. Some of the authorization, we did have some hiccups. NTP, you know, control plane policing is a little bit lacking in very detailed ACLs with the, you know, Sonic OS, but it worked out for us. It's okay. And then ECMP and SSH and those basic features. We really don't run that many features on the core, so we have some confidence that it's quite supportable. We do get nervous if we start running a lot of features there. I just wanted to show that, hey, you know, there is, you know, this is just one of our boxes, 5,389 lines. You might be saying, wow, I thought this was simple. You have 5,389 lines in your configuration or config.db file, which is a nice JSON file that it takes in as configuration. But when you break out every ACL into formatting, so for those that haven't played with Sonic or looking at it, you can quickly see that the configuration can get pretty massive. So for those that plan to hand type configurations or do anything by your hand and not rely on automation, this can be very, very painful. Very painful. So for ZTP, you know, just wanted to kind of share, okay, what are you doing with ZTP? So what we do is we update the OS. This is where we actually have the most problems. Everything else comes up and it's actually pretty solid. Hey, did that switch come out of the factory with something loaded besides ONI? That has happened to us a lot of times, or it comes with their pre-OS, even though we ordered it without an OS. So we're trying to get better at it. Occasionally we have to go to the console server and kickstart it and reboot it with a command. So that's probably the negative side of the house that we're continuing to fix. We update the OS. We put some pre-provisioning items. So those are like containers like LDAP. We needed an LDAP container. We needed or application. We needed a ZTP, basically a Nginx container to host some of the ZTP stuff for the leaf. So we put all those packaging ahead, and then we put the config.db, and then we do some post-provisioning items where, you know, for example, I know it's going to sound horrendous, but, you know, some of the SNMP queries weren't responding with certain things that we expect, like vendor name or even the hardware SKU. So we actually we went to the Python SNMP and manually kind of fixed that. So these are some of the things that you have to be ready with. You know, you might be asking, all right, man, that's a lot of work. I mean, was it worth it? I'll talk about that experience in a little bit. That being said, you know, some might be curious, okay, how is this stuff connected? 400 gig DR4, 100 gig DR, and et cetera. I think the key thing here is to understand, you know, how we actually did the structure cabling. So for those that are interested in doing 400 gig, 32 by 400 on one side, but also doing 100 gig ED on the other side, how does that end-to-end look like? So this is just a quick example for those. This is our sample pilot environment for those that are looking into, okay, what kind of structured cabling should I put in, and et cetera. So hopefully that kind of gives a little bit of visualization, so you can see that, hey, there's the 2-meter DAC 400 gig E, and then here's the T1s, and then these are the T2s, and we look at the leafs as T0, the tier 0 nodes. So hopefully that helps in kind of understanding what are the features running, what are the tools we're using, how we're actually using the ZTP, what's a sample config like, how big is it, and et cetera. So net, just to kind of summarize all of this, we had to stay very boring on the features. So we focused on making sure that the advanced features are happening on the leaf side. So you might ask, okay, don't you have those customers that need L2 stretches? Yes. So for those customers, we call it business as usual leafs, and those are running EVPN. You might throw up in the fact that we do actually full mesh BGP, so we don't have to rely on a route reflector because we put those close to the firewall. So when one security zone needs to traverse to another one, it has to kind of trombone through the firewall. So in that case, we actually put that device closer to what we call at a higher layer where it connects all of our suites. So we do actually a full mesh with the border leafs, and then if the border leafs go away and I still need east-west traffic, it still continues. Since we're automating, it sounds horrendous, but it's not that bad. It's actually easy to create the BGP configurations for full mesh, even at a pretty decent amount. And we don't allow EVPNs to go beyond a suite. In that case, we start asking a lot of questions. The other thing that I have to recommend is make sure you do your cost homework up front. We did a lot of this, and then we come to find out that commercial solutions became a lot more cheaper. So that calibration back and forth, we went through a lot of that. Obviously, you saw the title of the kind of whole thing is, we kind of went vertically integrated because we just don't have the staffing to say, okay, is this transceiver, that transceiver, this transceiver all certified, and then having it completely decoupled. We just don't have that staffing to do every testing permutation. So we kind of stuck it with that somewhat vertically integrated competition stack or fabric stacks. Human configuration, impossible. So if you're used to a lot of that stuff, it's not going to be a fun experience. We had to hack to fix a lot of stuff. We had to go into SNMP for things that are not returning it. We had to hard code it and then automate it and fix all of that stuff. We had to load containers, for ZTP related stuff. We actually had to, put LDAP on to get things working. One of the cool things was that, Broadcom, contributed to ZTP package, and when we tried it out on the other ones, it worked perfectly. They took that code, built it into their Sonic, release, and it actually worked. So we were actually pretty impressed. Yeah, it's nice to see community features are kind of working across the two. I know it sounds simple, but when it does work, it's pretty cool. Single mode, I think the cost inflection point is there. Actually, in some cases, it's cheaper, and it gives you that I don't have to have a short range optic and a long range, so it makes that decision go away. So you can actually build out your infrastructure, and then we did achieve, some silicon diversity, as you saw our earlier stack. But is it a good thing or not? It's something that we're trying to figure out. I think it is. We'll get back. So how many of these racks came in with this bring your own tour? Does it happen that much? Yeah, we have 120. It's a good start. I mean, we just got this kind of rolling. So for now, that's a pretty decent start. Did the sweat equity that we put in pay off? I mean, we really definitely rolled up our sleeves. Obviously going this route, it's a lot of rolling up your sleeves and working at it. So, I hope so. I think so. We have some data pointing at it, but until running for a longer time or a real outage happens, it's really hard to understand. Like, maybe post regrets might kick in, but maybe in the future I can kind of update everybody who are curious on where kind of journey is. But hopefully that kind of gives a little bit of a snapshot of what we kind of built, how we actually served our customers, and kind of put a solution together the past year. Fortunately, I had a really good team, very small, but worked really hard to kind of get this going, and it was kind of nice. So that's pretty much what I wanted to share with everybody.